Leaving Cert Higher Level 2015 Paper 2, and this is question 6, not question 3. And you were asked to do the centroid construction. So your knowledge for centroid is midpoint to vertex. So there's a couple of ways to do it. You could measure the length of this side with a ruler, write down your measurements. So you could say maybe that AB, I'm just going to estimate here 10 centimeters. So you get your ruler, you go to 5 centimeters, and then draw your line to the vertex opposite point C. And then we could measure BC. So it's 9 centimeters. So we're looking at, I'll put my 5 centimeters on here, we've divided this in half. We're looking at both of these being 4.5 centimeters. Now I don't have the app to do constructions on this, but if we go straight through there, this is my centroid. So just a couple little things you need to know for these constructions. You could also use the perpendicular bisector that you would have done at junior cert as well, but measuring the angle is probably the quickest way to do it in the leaving cert. So that's the centroid. Second part of this question is Theorem 11. Let's have a look at that. Part B of this question is Theorem 11. Prove that if 3 parallel lines cut off equal segments on some transversal line, then they will cut off equal segments on any other transversal line. And within all these proofs, you're given sections that you have to fill out: the diagram, what you've been given, the construction, and the proof. So let's have a look at our diagram here. 3 parallel lines. And we need to draw 2 lines, one going in this direction and one going in this direction. And we need to give these points so we can name the lines. So we've got 6 points here. We may as well go A, B, C, D, E, and F. And what we can say here is that AB, these are my 3 transversal lines. What am I given? 3 parallel lines. AB is parallel to CD, which is parallel to EF. And I can either take AC is equal to EF or BD is equal to DF, and I always like doing the one on the right. So let's look at these two being equal. So the transversal line. So BD is equal to DF. And what we'd have to prove then, which I actually left out, did I? No, I left out under given, I should have written, and I have to prove that AC is equal to CE. Okay, let's look at our construction. So my construction is to draw a line parallel to AE, leaving B. So let's do that. So parallel to AE, leaving B. So something like this. We want to create parallelograms here. So that's going to be a parallelogram when we label this point. And I need to create another line parallel to BF, which will give me similar triangles. So something like this. So I'm going to label these. So I'm going to call this one E prime. And I'm going to call this one B prime. So we're just going to write that down. And I'm going to give these 2 points as well. We'll call this one C prime, and we'll call this one D prime because they match off with those letters on the other lines. So my construction, so I'm going to say draw B E prime parallel to AE, and we're going to say mark point C prime. We can say on what line? On CD. Similarly, I'm going to draw E prime, B prime. And that one is parallel to BF. and mark point D prime on the line CD. So let me go over these in different colors so we can see what we're doing here. So the first thing we're going to say in our proof is we're going to say that this one is equal to this one because they're opposite sides of a parallelogram, which would be equal to BD because DF is equal to BD. So let's write that down. D prime E prime is equal to, what do we call it? DF. And the reason why, opposite sides in a parallelogram. And we know from up above, we know that DF is equal to BD. So BD is equal to DF. So we can say therefore that D prime E prime has to be equal to BD as well. So now we go back up to our diagram, we can say that this one has well and give it two lines. It's the same as this green one here. Now what else can we say? We can say this angle and this angle are the same because they are alternate. So we'll give them letters now in a minute, and we can say this angle and this angle is the same because they're vertically opposite. So let's see how that will help us. So we can say, just jot it down here, the angle DBC prime, DBC prime, the angle DBC prime is equal to the angle, what was the angle down the bottom? C prime, E prime, D prime, C prime, D prime, E prime. So let's do dark circles. So the open circles, this one here, we could say angle 1 and angle 2 if you wanted to, but we're giving them letters in this case. So this angle here that I'm making bigger is BC prime D, BC prime D. Is equal to one opposite, vertically opposite angles. So that's E prime, C prime, D prime. E prime, C prime, D prime. So this one is vertically opposite. And this one is alternate. So now we can say that these two triangles are congruent. So I'll just get the letters now. Triangles are congruent. So what are they? What are the two triangles? We have BDC prime, BDC prime, and triangle E prime, C prime, D prime. Therefore, sides are in proportion. So we can say, we jump back up, we can say therefore D from the dark circle to the open circle and the dark circle to the open circle, this one here, I'll give it 3 lines just to highlight it. These two must be the same if the triangles are congruent. So therefore BC prime is equal to C prime E prime, BC prime is equal to C prime E prime. So we jump back up and finish it off. We said that BC prime is equal to C prime E prime. So we also know we've drawn that line parallel to this line. So therefore we can say that AC, I'll just finish it off up here so we can see the diagram. Therefore AC is equal to BC prime, opposite sides, parallelogram. And C prime E prime is equal to CE. You can just write as above. Therefore, we can say that we're trying to prove, if you look what we're trying to prove here, AC is equal to CE, and we can now say that because C prime E prime is equal to BC prime. So therefore, that just finishes it off. AC is equal to CE. That's that proof complete.